Describe the shaded region in each graph with the appropriate inequalities. For graph A, we first of all want to notice that the shaded region is strictly below the dashed line. It's also on or to the right of the y-axis and on or above the x-axis. So our strategy will be to write an equation for each of the boundary lines and then decide the appropriate inequality that goes with each of the equations. So let's start off with the dashed line. The first thing we might do would be to identify the intercepts. The y-intercept is 3. The x-intercept is 2. From the intercepts we can determine the slope, and we know the y-intercept, so we can write the slope-intercept form of the dashed line. Y is equal to the slope. Well, from the y-intercept to the x-axis we have to go down 3 and to the right 2. So the slope is minus 3 over 2. We multiply that by x and then add the y-intercept, which is 3. That's the equation of the boundary. However, we want the region that is below the line. So we'll use the inequality less than. So below the dashed line, instead of using equal, we're going to use less than. Y is less than minus 3/2 times x plus 3. Now we do want to double check and make sure that we've selected the right inequality. We can use a test point. We have this point right here, 0, 0. When y is 0 and when x is 0, we get the inequality 0 is less than 3. That's true, and so we know that we've selected the appropriate symbol for our inequality. Alright, next the region is to the right of the y-axis. So we're going to go ahead and find an equation for the y-axis and then determine the appropriate inequality. Along the y-axis we've got different points. We've got the point 0, 0, 0, 1, 0, 2, 0, 3. Notice that all those points have the same x-coordinate. The x-coordinate is 0. So the equation of the y-axis is simply x is equal to 0. Now for our region, the x values are, well, the x values can be 0 on the x-axis, but most of the points are to the right of the x-axis, and when you were to the right of the x-axis, the x-coordinates are positive, so we know that the x values have to be greater than 0. So the inequality that describes to the right of the y-axis, or on the y-axis, is x is greater than or equal to 0. And if we pick this x-intercept here, 2, 0, the x-coordinate is 2. 2 is greater than or equal to 0. And then finally, the last thing we need to do is to write an inequality that describes the points that are above the x-axis. So we first of all write an equation for the x-axis. All the points on the x-axis have a y-coordinate of 0, 0, 0, 1, 0, 2, 0, 3, 0, and so on. So the equation is simply y is equal to 0. But the points in our shaded region have y-coordinates that are positive, so our inequality will be y is greater than or equal to 0. So these three inequalities together describe the shaded region in graph A. We can find the inequalities that describe the shaded region in graph B similarly. Let's start with the dashed line. The x-intercept is -1 and the y-intercept is 2. So the equation of the dashed line is y is equal to the slope. Well, in order to go from the x-intercept to the y-intercept, we need to rise 2 and run 1. So the slope is 2 over 1, which reduces to 2, multiplied by x plus the y-intercept, which is 2. So y equals 2x plus 2 is the equation of the dashed line. However, our shaded region is below the dashed line. So the associated inequality is y is less than 2x plus 2. For the solid line, we have the same x-intercept, -1, but our y-intercept is different. It's +1. So the equation of the solid line is y is equal to, we need to calculate the slope. From the x-intercept to the y-intercept, we rise 1, run 1. 1 over 1 is 1, so we get y equals 1x, which can be written simply as x. And then plus the y-intercept, which is 1. So y equals x plus 1 is the equation of the solid line. But our shaded region is above or on the shaded line, so we're going to use the inequality greater than or equal. So y is greater than or equal to x plus 1. These two inequalities together describe the shaded region in graph B.